Welcome back, student. In the previous lecture video, we already discussed on air-cooled condenser. We know actually the condenser basically three types depending on the condensing medium. That is basically air-cooled, water-cooled, and evaporative condenser. Okay. Now, in the previous lecture video, already discussed on air-cooled condenser, in which the condensing medium was air, and there are basically condensive is a natural convection, forced convection, air cooled condenser there. Okay, and there are one disadvantage also there, that actually what happens in air cooled condenser, we already gone through this in the previous lecture video. Now in water cooled condenser, what you see here, that the condensing medium is water, so that's why name is water cooled condenser. So water used as a condensing medium. Okay, and we know that air cooled condenser are basically used for your basically domestic purposes, like for your household refrigerator, or like small capacity unit. But water cooled condenser has highest capacity to condensing of medium, so it is used in commercial as well as industrial refrigerant units. Okay, this is the most important difference between air cool and water cool, and most advantageous point is basically that it is used for commercial and industrial refrigerating units. Okay, this is the water cool condenser. Now obviously that the water cool condenser are basically used in which actually the adequate, obviously the uses of huge amount of water supply should be there, so that the water cool condenser working takes place, takes place. So the adequate supply of water is important. Adequate supply of water is very much important. If you use your water cooled condenser, so adequate supply of water is very much important. So if the supply is sufficient, then you can use your water cooled condenser, but this condition should be satisfied when you use your water cooled condenser. Okay, and obviously the it is highest capacity because of water cooled, the condensing temperature is compared to the air cooled condenser is very much less, so that the required work done or required power for the compressor work done is less. The if in between water cooled and water cooled and air cooled condenser, the efficiency of water cooled condenser is very much high. Okay, no doubt about that. Now obviously the water cooled condenser may be other two water system actually there. One system is wastewater system, the name suggests wastewater system. Another one is recirculated water system. Okay, basically this wastewater system, what you see here, that basically a vicious cycle in which the condenser is basically important here. Like, so what vapor refrigerant from the evaporators comes in the compressor, from the evaporator, actually vapor refrigerant from evaporator comes into the compressor, in which the compress the vapor refrigerant, and it goes to the by discharge line hot vapor refrigerant to the condenser. This is your condenser. Okay, so this is your condenser, and here that is in the water cooled condenser. So there are condensing tube are there. These are the condensing tube. Okay, in which the hot vapor refrigerant enters here, and these the basically condensing tube are there, basically steel or copper tube are made of. And obviously there are water supply are there. So basically these are the water supply from the city main sections. You can enter these sections, and after condensing the warm water is come to the sewer. So when it is hot vapor refrigerant, when the process is complete, the hot vapor refrigerant transform into liquid refrigerant, which is basically in this way the liquid refrigerant comes out and to get received. So basically the wastewater system. So as the name suggests, this is a block diagram. Okay, so this is the block diagram of wastewater system. But in wastewater system, what happens actually, the water after circulating in the condenser, the water after circulating the water after circulating in the condenser, so this is the water enters into the condenser. This is the water enter into the condenser, they circulate. Okay, they circulate into the condenser and discharge it to the sewer. So it is when it enters to the condenser, the circulating air, the cold water actually contact with the copper tubing of the vapor refrigerant which flows actually, and they reject heat to the cooled water, and the cooled water transform into hot warm water. So warm water, and this warm water is transformed and discharged to sewer, ACWER. Okay, and this system is basically is used in small unit. Okay, this system are used in small unit. It is used in small unit. And one more point, and obviously, as you know, that the water circulating system are there, so obviously no doubt about that, there should be some system in which the location where the large quantities of fresh, inexpensive water and sewer system large enough to handle this wastewater, and that are available. Obviously the availability is important point for this wastewater system. So two important point is that it is basically used for the small unit as well as this is used for small unit. And one more point, that a location where large quantity of fresh water and the drainage system is important, large enough to handle the wastewater. Okay, so this is the important point, that in which the water cooled condenser is basically works. Okay, so this is the system in which the condenser can be cooled. Okay, now the next point is recirculated water system. Now recirculated water system, so as the name suggests, that recirculation or recirculated, so that means it's basically recycling. Okay, so as the name suggests, recirculated means recycling type of, that indicates that type of terms. So what you see here, there is a compressor are there, so hot vapor refrigerant enters into the compressor, the compress, and that vapor refrigerant transform into hot vapor refrigerant. It enters into the water cooled condenser, in which the condenser tube are there. So these are the condenser tube, that condenser tube are there. So this condenser tube, and beside that cooling water or cooled water enters into the condenser, in which the cooled water contact with the condensing medium or condensing surfaces, condenser tube surfaces, or copper tube surfaces, and it reject heat to the cooled water, and the hot warm water it exit. When it is hot water, warm water, that it exit from these sections, and that enters into the some cooling water tower. So in cooling water, that will the after when it reach into the cooling water, after cooling water reach it, obviously that flows into the again condenser heat pump to cooled water. So this is the system, this is a recycling unit, and when it is hot vapor refrigerant reject heat and they form liquid refrigerant, it will be reject to the receiver. So this is the basic block diagram of this recirculated water system water cooled condenser can works. Okay, but what happens in recirculated water system, it happens actually the same water circulating in the condenser is cooled and used again and again. This is the most important point. Just note down that same water, because there is no usage or no source are there. What is the source? You can use again and again. Okay, so source is constant. So the same water, just note down point, the same water circulating in the condenser, is cooled and used again and again. Okay, so this is basically why this type of system that you can use again and again. And this system are basically some type of cooling devices also are there, some type of water cooling device, and the cooling water towers and spray ponds are the most common cooling devices used in recirculated water. So this is the cooling water that it can be used as a cooling water or cooling tower like that. Okay, and the warm water from the condenser is led to the cooling tower. So this is the warm water, and this warm water. And the next, depending on the construction, water cooled condenser basically are three types. Okay, depending on depending on the construction, these are the types. Depending on the construction, water cooled condenser, basically three types: tube in tube, first one; second is cell in tube; and third one is cell and tube condenser. Okay, first one is tube in tube. Tube in tube, as you see that this is the water in section, is the water flow through this channel. Okay, and hot vapor refrigerant enters into this section, and it can goes up to these sections. Okay, actually this hot vapor refrigerant contact with the cooled water. Okay, is contact with the cooled water, and they reject heat. When it reject heat and the cooled water is transformed into hot water, they will come out from that sections. And the hot vapor refrigerant cooled by means of rejecting heat to the cooled water, the hot vapor refrigerant is transformed into liquid refrigerant. So this is called tube in tube. So liquid refrigerant. So this is the block diagram. But what happens in tube in tube or double, it sometimes also called double tube condenser also. Double tube condenser. Okay. And it's basically what you see here. There's a consist of a water tube inside a large refrigerant tube. So this is the water tube and inside a large refrigerant tube. And in this type of condenser, the hot vapor refrigerant enters at the top of the condenser. This is the entering positions. Okay, and the water absorbs heat. So as the contact with the, when the hot vapor refrigerant contact with the condenser tube, so obviously the water absorbs the heat from the refrigerant, and the condense the liquid refrigerant, and that flows at the bottom. Okay, that is basically, you know that the heat transfer or heat exchange, basically two types of parallel flow system and counter flow system. So go through that on that. So you know that what is tube and tube. So this is the tube and tube water cooled condenser. And next thing is cell and coil. So as the name suggests, cell and coil. So in the coil sections, the cooled water is flow through this channel, and hot vapor refrigerant into this section. Okay, into these sections. So when hot vapor refrigerant enters into this section, so cooled water comes into the takes place, contact with this hot vapor refrigerant, and as it is contacted, obviously the vapor refrigerant transform into the liquid refrigerant. Or it is transform, or it just convert, already fully converted into liquid refrigerant. It just come out from this channel, and that will basically goes to the receiver. Okay, so this is the basic principle of the cell and coil condenser. The cell and coil condenser is basically consists of one or most important one, that in the cell and coil condenser, basically one or more water coils are enclosed. Okay, one or more coils. So this is the one or more coil. It can be like that, it can be this type manner, it can be this also. So this is the one or more water coil are enclosed in a steel cell. This is the steel cell, this made of steel. Okay, and both the fin and bear type coils are available. So it can be the cell and coil condenser, maybe vertical or horizontal. It can be in this type also, it can be this situated in this type also, it can be vertical or horizontal. Okay, so most vertical cell type condenser basically are counter flow system. So this is called cell and coil type condenser, in which the coil in the coil form of condenser, the water flow enters into this section, and water flow from that section, so hot vapor refrigerant enters. So again, the cell and tube condenser, so cell and tube also same as type as like cell and coil condenser and tube in tube condenser. Cell and tube condenser also same. It's basically concentrated. It consists of a cylindrical steel cell. It basically consists of a cylindrical. Just note down the point first. Cylindrical steel cell. Okay, so basically the cell are basically form of steel. Okay, and containing a number of state water tube. and in the same manner the condenser works, okay, in cell and tube condensers. These are the three types of condenser, basically tube and tube, cell and coil, and cell and tube condenser. Okay, thank you very much for listening me and watching me. Goodbye.